Once again, good evening all. I welcome you all to the week 12 live session for the course Characterization of Construction Materials. Every week we have 3 live sessions on Monday, Tuesday and Friday, and today we tell you the Tuesday live session. And in this week, we'll be seeing content from electrical methods, and I'm Nilakanmani. I'm a PhD student from IIT Madras. So this week we'll be seeing about electrical methods and how we are going to test concrete specimens using electrical methods and what we are going to interpret from the electrical measurements. That's what we are going to see in this week. Okay, let me post the first question for this week. I've already launched the question and polls. Please don't answer immediately. Please wait until I discuss the question in the class. Okay. So here is the first question. Is a very simple question. The electrical impedance spectroscopy is a technique used to study the which of the following property of concrete. Okay. So and this is the final week for this course. So you would have heard about phase composition, heat of hydration, resistivity, oxide composition as well. So electrical impedance spectroscopy is what discussed in this week. So which is the technique which using that what we can study? That is the question. Let me start the timer for a minute. Please give your answer in polls, or at least if you're not able to do that, you can type the answer in chat box. Time is up. Let's see the class response. Okay. No answers in chat box. Fine. Checking polls. Okay. Someone of you have felt phase composition and 2 of you have given resistivity of specimen. Fine. Let's see what is the right answer. So here electrical impedance spectroscopy, here the impedance itself indicates we are going to measure resistivity of concrete using the impedance plot. So this is one of the impedance plot. Here we can measure resistivity using this, and with impedance we can understand how does the concrete structure evolves with the impedance measurement. Okay, so the correct answer is resistivity of specimen. Fine. Let's move to next question. It's a very simple true or false question. The resistivity values that is obtained from the Venner 4-probe surface resistivity instrument. I don't know about the previous instrument, electrical impedance spectroscopy. It's quite difficult to maintain in labs. It takes a lot of effort to maintain that. It requires a clean lab without even though it deals with corrosion measurement. With that we can do. It can't sustain corrosive environment. But in this case, Venner 4-probe surface resistivity instrument can be quite commonly found in labs. So in this there will be 4 probes from the main rod, and then we just press this over a concrete specimen, then we'll measure the resistivity. Okay, I think regarding from which where the resistivity is measured, between which probes is the question given in the current assignment, I guess. So this question is resistivity values obtained using the Venner 4-probe surface resistivity instrument are dependent on temperature. Is that so? Is temperature does have an effect on resistivity values? Let me start a timer for 30 seconds. Please give your answers. This question is launched in polls. I request everyone to type the answer or at least give the answer in chat box. Time is up. Okay, two answers have been, okay, totally four answers. Two of you have found it's true. Okay, false. I think there is some confusion here. We'll discuss. So, uh, I think, ouch. Yeah. So, before going to resistivity, we can discuss about conductivity. When it comes to conductivity, when there is increase in temperature, there will be increase in conductivity, right? If there is increase in temperature, the movement of ions can be increased, so conductivity will be high, right? So in the same case, if there is increase in temperature, obviously the resistivity will decrease. And there is a increase in temperature, obviously resistivity will decrease. So obviously if resistivity values are less, obviously it will affect it have an influence on the concrete quality, right? And when we see there is a decrease in temperature, obviously the resistivity will increase. Okay, so temperature has an effect. So the correct answer is true. It affects. So here is the next question. Moisture content of concrete specimen. It's again about Venn-4 probe only. Moisture content of concrete specimen does not affect the resistivity values obtained using the Venn-4 probe surface resistivity instrument. Is that so? Again, I'll start the timer for 30 seconds. Please give your answers. I think regarding saturation, properly saturated or not, like that, sir has discussed results on how is there any effect of moisture content on the resistivity. So if you followed the lecture, you will be able to give a correct answer for this question. This question is also launched in polls. Time is up. Okay, here I could see some correct response. Yeah, the correct answer is false because moisture content will have an effect. Does not affect. It's actually not a correct statement. So okay, let me end the poll here. So whenever students do this whenever surface resistivity test, they used to even it will the specimen will be taken from the curing room, but at a time they used to bring four to five specimens together, and like once they start doing the specimen one, obviously the fifth specimen can go dry, right? Or again, what they used to do is like uh, they bring one specimen at a time, or else if they bring more specimens, they used to put them in water. Play like normal water, and then they take it out and then they dab the surface and then they used to measure it. It should not be wet, but it should be saturated. That is what they used to follow in our lab. Okay, and this statement is taken from the lecture PPT only, like testing while concrete is dry gives high resistivity and testing while saturated gives conservative values. So uh, uh, we should be very keen on how does the test is done. And similarly with compressive testing or compression test on cube also does have an effect on this dry and saturated values. If you have done compressive test on concrete specimens, you would have known this. And the correct answer is false because moisture can have an effect. Let's move to question number 4. Here, which of the following systems can be used for testing a Venn-4 probe surface resistivity instrument with an electrode spacing of 39 mm? Okay, so here uh, in the limitations or points to be considered for Venn-4 probe surface resistivity instrument, they have explained what should be avoided or what should be done carefully. Like the in before case we discussed about the moisture content or saturation, right? Like that, how the length of the specimen, minimum length of the specimen is also discussed in the lecture PPT. So here they have given an electrode spacing of 38 mm, which means A is equal to 38 mm. So which of the following specimens can be used to do the study? It has more than one right option, so it's you can't give the answer in poll, so I didn't launch. So please type your answer in chat box. Okay. I think someone have given an answer. I request everyone to type the answer in chat box. I think time is up. Okay, two members, only two of you have given the answer. One has given A and D and one has given C. Okay, let's see what is the right answer. So here, probe spacing has to be sufficient so that representative average resistivity is measured. So here they have said that there should be sufficient spacing between the probes, and depth and width of the member should be at least 4 times of the probe spacing. So they are saying that there should be minimum spacing between the probes. You can't just put them very close. There are 4 probes, right? That should not be very close. And as per the specification given here, it should be 4 times the length of the specimen should be at least 4 times. So in that case, if you multiply 38 into 4, what will be the number? Okay, wait, let's calculate. 38 multiplied by 4. So it will be 152. So in that case, yeah, it's not, if you consider B is not a right answer, if you exactly calculate the number, but should but since it's close to 152, I've given B as a right answer. But in that case, B cannot be right answer in that case. And if you see C1, the depth and should be at least 4 times, right? So in this case, the length to depth ratio is 2, right? So if the dia of the cylinder is 100 mm, what will be the depth length of the cylinder? It will be 200. It will be 200 mm. So obviously 200 is greater than. Here I'll write it so that if you see the slides in future, you'll be able to follow it up. So 38 is A, right? Okay, so it. So A is equal to 38, right? So in that case, it should be 4 times. So 4 multiplied by A is equal to 152. So in that case, if the electrode spacing is 38 mm, we in practical purpose we just consider to use it. But if you consider as per calculations and with NPTEL and marking and all, yeah, this is a wrong answer. This is not right answer. And if you compare C and D, obviously, if you see L by D is 2, so the length will be 200 mm. So in that case, this can go, and If it's 150 mm, obviously it will be 300 mm. It's far greater than 152 mm. So this is also right. I hope you guys got it right. Okay, so the correct answer will be C and D. If you considered B also, it's okay for now. Okay then. Let me see if you guys have posted any queries. Okay, fine. There is nothing. So here is the fifth question. The electrical properties of concrete studied in saturated state of the specimen can be used as an indicator of. This also has more than one right option. Okay, so only one option. If you give, it will not be appropriate. It has more than one right option. So which of the following can be indicator of electrical properties like conductivity or resistivity, whatever you measure from the concrete? First option is the ionic strength of pore solution. B is interconnected porosity, and C is total porosity, and D is inaccessible porosity. Okay, let me start a timer for a minute. So in this case, if you see here, they are talking about electrical properties of concrete. So in electrical properties, majorly we measure resistivity and conductivity, right? So in that case, why the concrete is conductive? There should be something in concrete, right? That is responsible for the conductivity. If there is resistivity, why like if it's conductive or less conductive, there is some reason because of that. So which of the following can be a representative of that electrical property? I'm just for discussion, I'm discussing about conductivity. Time is up. Let's see what answers you guys have given. Okay, one of you have typed A and C. Let's see. I could not see any answers from rest of the people. Why the questions are really difficult to answer? I request everyone to watch the video and come for the live session. And hereafter, we'll have only four more live sessions left: two on Fridays and one on Monday, one on Tuesday. Okay, so regarding that, I'll discuss by the end of the session. Now, let me finish this question 5. So, if you see which of the following properties, it's A and B. Okay, so why concrete is conductive? Concrete is a solid, right? Why it should be conductive? It should not have any conductivity, right? If you take a dry, uh, let's assume a thermocol board, will it be conductive? No, right? So how come a concrete is a solid, right? Why it's conductive? That point is that kind of question should be there. Why it's conductive? So if you listen the lectures, they would have given you the answers. So concrete is not a complete solid. It has solid phase, it has liquid phase. Like in the pores, there can be pores, and in the pores there can be air and there can be water as well. Water, in the case, it's not exactly water, it's pore solution, because cement concrete has lot of ions in it. So concrete itself, cement has a lot of ions, so that will get into the, there will be small pores. Since the water is very less, obviously the ions from the cement will get into the solution. That's why it's called pore solution here, right? It's not called water, right? It's called pore solution. And with the, like, currently we can extract that pore solution from concrete samples, like high pressure, like 400 or around 800 MPa. If you apply, we'll be able to extract the pore solution above 400, I guess. I'm not so sure about the values of how much you have to compress the cement paste. So from that, we'll be able to extract the solution. And with that solution, we'll be able to understand which ions are more in the particular cement system, and we'll be able to understand how it can affect the durability properties or concrete quality. If you have added some fly ash, and what changes it had made to the pore solution composition, right? If you try to test, there will be where is I don't, okay. So there will be ions. In the case, there can be potassium ions, there can be sodium ions, and I'm just talking about the alkalis here, and there can be OH minus ions, and at times there can be silica and aluminum also, but that their quantity will be very very less with time, and there can be sulfur ions also. Okay, I'm just putting a cap since it's cement chemistry. That's S should not be Si means it's silica, but in cement chemistry notation we use S for silica, so just I put a cap here. So there can be sulfur ions. So and silica and aluminum ions can also be there. Since they are very very reactive when we compare, so they might have formed CSH like that. Okay, so if you try to understand this pore solution, we'll be able to understand what kind of changes that if you take only OPC, there will be more potassium and sodium ions. Then if you added fly ash to it, is there a decrease or increase in the potassium and sodium ions? That we'll be able to understand. Okay, so that mainly these ions are responsible for conductivity, this potassium, sodium and hydroxyl ions. Sulfur, I have no idea about how much sulfur can affect conductivity, that I'm not so sure. So let me put that out of discussion now. So, and when it comes to porosity, if these pores are not interconnected, even though it has an ionic solution in it, like pore solution in it, that will not be conductive unless you have a small connected pores in between this. See if it has, if a system does, if you take on, if you divide it in the middle, if this side pores are connected, and if you measure this side, the conductivity will be more. But if you take this side, there is no conductivity at all from one port on another port. So even though there is a lot of porosity, even there is total porosity or inaccessible porosity, that doesn't matter. Unless the porosity is interconnected, we will not be able to understand. So if you measure conductivity out of it, unless the pores are connected, we will not get much conductivity. So from that case, we will be able to understand interconnected porosity and the ionic strength of the pore solution. Okay. So now let's move to question number 6. Here posted a graph here. So here we have measured surface resistivity using Venner 4 probe resistivity instrument. Okay. So here we have measured the surface resistivity for different cementitious systems. This snap is also from the lecture PPT only. Sorry. Sorry. So okay. I have measured surface resistivity of different cementitious systems. First one is the OPC, and OPC with 50% of slag, OPC with the 15% of slag B, like that they have added 30% of slag B, 50% of slag B, and then 15% of class of fly ash, 30% of class of fly ash, and it's weighed from 15, 30 and 15, 30 and 50% of class of fly ash, and then 15 to 30% of class C fly ash. So here when you compare OPC system, what you can observe with the SCM addition to the ordinary Portland cement. Is there a increase in resistivity or decrease in resistivity? And so from that you should interpret, does SCM addition to OPC is beneficial for concrete quality or not? Okay. So I'll wait for a minute. Let me start a timer for a minute. So uh, in lecture PPT, sir has given these values, and they have did some qualitative analysis and told if the resistivity is from this value to this value, then it's called the concrete quality is really good. If the thing is between this and this, it's extremely good or very poor, like that they have given some indication, right? So from this you should understand, if just compare with OPC and with the and cement with OPC. If it's 15% slag A, means 85% is the OPC and 15% is slag A. Okay. So just compare and see the values and please give your answers. I request everyone to give the answer. This doesn't require any understanding. It requires understanding, but even if you didn't watch the PPT, you should be able to answer this question. It's a very very simple question, and just understand the graph and give your answers. Already time is up, but I don't want to leave the screen as of now, because if I move away from the screen, you might not be able to. Okay, let me do this. I'll keep the screen and I'll try to open Google Meet as well. Okay, somebody have given option A. Oh, where does the PPT go? Oh, if I touch the screen, it might leave, it seems. Okay. Option A, option A. Unfortunately, my mouse is not working. Okay. Most have given A. Okay. Yeah, yes. So let me move to the next PPT. Thanks for giving the answer. So here, if there is an addition of SCM, obviously there is some increase in the resistivity, right? If there is increase in resistivity, which means the movement of ions will be restricted. If that is there, obviously it will help with the concrete quality, because the movement of ions is the primary reason for if chloride is there in the system, it's not there in the system. Like if due to some external source, considered to be a marine environment. Obviously, there is a lot of chloride in the from the marine environment, right? So, if the chloride can just if it comes to the concrete surface, so on the concrete surface till the rebar there is a cover, concrete cover. So till if it has to reach from concrete surface to concrete rebar surface, it has to it has to travel this path. Okay, so in that case, if the concrete has a good resistivity, obviously it will restrict the movement of ions. So if the resistivity is high, it will have good concrete quality. So in that case, addition of SCMs to OPC system is beneficial for concrete quality. Okay. Now let me move to the next question. So this question you have to look at this graph. Okay, for the moment I'll maximize the screen, or else you'll not be able to see the graph properly. Okay, this question is, yeah, this particular thing is they have measured the conductivity of cementitious system, and from that from the conductivity they have measured the derivative curve also. Okay, so consider the derivative curve and give your understandings here. So what does the point here A mean, and what is the point here B mean, and what does the point C here mean? Okay, so they have measured cement conductivity or concrete conductivity from the point of mixing water to the cementitious system. Okay, so once they have mixed water and prepare sample, and they have framed a small specimens out of it, specimen sizes, and to the end there will be a steel plate attached to the concrete specimen, and they'll measure the concrete conductivity. Okay, so here what does A mean, and what does the period in between A and B does it represent, and what does this B here mean, and what does C mean? There is some difference here, right? With reference to derivative of conductivity, there is some changes here. There is some decrease and there is some increase. So from here, what you are able to interpret? Uh, just think, we have all undergone like the first week, second week lecture is isothermal calorimetry. Using isothermal calorimetry, we measured the reactivity of cement, and we measure the heat of hydration, heat flow we measured. From that we'll be able to understand what is the heat of hydration of different cementitious systems. So from that we'll be able to understand what is the uh, 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 like initially there will be heat of wetting, and some other things will happen, right? Followed by there will be decrease in the heat of heat flow, and suddenly there will be increase in the heat of flow, and there will be decrease in the heat flow. If you can remember the heat of hydration curve, from that you should understand this and you should interpret something. You can type the answers in chat box. I'll let me try to minimize this thing here, and then I'll come there. For the moment, what I'll do is, let me start the timer for 2 minutes. Please take 2 minutes and type whatever you understand from the graph. And this is already explained in the lecture PPT. If you have watched the video, you should pakka answer. Okay, I've maximized the graph size. Let's see. Ouch, something is happening here. Okay. Please type your answers. Oh my god, this ABC went bad. Okay, let me read it for the moment. So try to understand what does A mean and what does A to B mean and what does B mean and what does C mean. I could not see any answers here. Okay, let me do one thing. Let me compare these two rings. Like this is heat of hydration curve of cement. 2 minutes are over. I think I also used most of your time. So now you should be able to compare this. Okay, so here they have mixed the cement with water and then they have measured the conductivity. Okay, so here from the moment they have ordered water, they measure the heat of hydration here. So how you can relate this both? Here there is some, at least what does this mean? A mean? Will you match it to induction period or accelerating period or decelerating period? What does B mean? Will you link A to which of this? Induction period or accelerating period, deceleration or deceleratory period? Like that you have to match A, B, C to induction, acceleratory, deceleratory period. I do not see any answer. Oh, sorry. Mm, I think this is discussed in the class, I feel. Yeah. And tomorrow is the last day to submit the assignments, right? Mm, guys, please. Okay, fine. Okay. Let me. I don't want to waste any of us time. So what I'll do is I'll try to explain this. So if you compare these both, if you see there is a sudden heat rise. This is because heat of wetting, right? And followed by there is a sudden drop in the heat of hydration generated. That's fine, right? Here there is a drop, and here with conductivity also there is a drop here, right now. So why this is happening? There is a drop in conductivity and there is a drop in heat generation also. So here we can listen that this period is induction period. Okay, so there is a drop in conductivity and the the heat due to hydration is also not releasing. It's getting decreased. So here we could understand the diffusion of ions is not much happening. Dissolution of ions is not happening. The If you add cement to water, the water will wet the cement and the ions like calcium, silica, alumina, the rest of the alkali ions will come out of the cement into the water and they start to react, right? So the dissolution of ions, there is a decrease in this time. Okay, after the immediate heat of wetting. So once you mix heat like water to cement, there will be sudden release of it because once you mix two phases like solid to liquid, and cement has a lot of ions in it. So immediately what happens, there is sudden burst of heat because cement has some amount of alkalis and alkalis are readily reactive. So what happens, the alkalis will readily get into the solution. So this can happen. And alumina kind of phases will have more heat generation also. So the sudden heat of wetting can be due to that. So here also we can see after that there is induction period, there is some decrease in the rate of heat generation. Here also there is some drop in the conductivity. Okay, so followed by this there is an increase in the conductivity, right? So here there is an increase in the heat of hydration, heat generation, right? Also, so from here we can see that B can be related to initiation of acceleratory period. So here there is some formation of phases like CSH, Schwittering, Portland, so that phases can be formed here. Okay, so followed by this, that there is not much increase in the conductivity. The conductivity is same as such. So here that can be understood. Followed by, there is a distillatory period followed with acceleratory period, and there is a slow period of slow continued reaction. Okay, so that we can interpret from here, and this thing is discussed in the uh, lecture PPT, and this can be used to alternatively to measure the setting time. In setting time you just get the values, right? Apart from that you don't see what's happening in between times. So if you use this conductivity measurement, you can have a follow up of what is happening at what time. So if you measure setting time, exactly at what time it happens, that is only you get at 30 minutes or 40 minutes what is the initial setting time, and followed by that what is the final setting time, that is only we measure. But here we will be able to understand more phenomena rather than doing setting time test. Okay, so this is the solution for the previous question. There is a dissolution of ion is decreasing here. Okay, this is the dormant period, and followed by the conductivity increases, which means the accelerated period, and there is no change in the conductivity. This can be understood by deceleration period and followed by the slow reactive phase, if you see both these curves. Okay, so this is the final question for the week. Thank you all. So before the thing winds up, I wanted to ask question to you guys. Like I request, I think your final exam is about to reach it. When is your final exam? Can someone unmute and tell? Let me stop sharing here. If you guys have any queries, you can ask me now. That is also there.
Ma'am, final date has not yet come.
Sorry?
Final date has not yet came.
Okay. Mostly it will be by April.
Three
Uh,
zero they told 30 do it like that, but till now we didn't receive any hall ticket and all.
okay. What is that date? Can you tell me again?
April 28 to April 30. That was the tentative date given at the time of enrollment.
Okay, fine. So let's assume April 28th. That is the case. Then, so this Friday we can have one live session. And next Friday having a live session is not possible, right? Because it will be difficult for you guys to follow. So still, Vipina, who's taking live session on Friday, will take two more live sessions, and me and Anupama will have two more live sessions on Monday and Tuesday. Okay. So in that case, Vipina will take the live session either in the week. She'll take a live session on Friday, and apart from Friday's live session, she'll take one more live session either on the Saturdays or Sundays. Mostly, I guess. Yeah, because we can't have live session on Wednesday and Thursday. So we'll see. Okay, so we are planning to take mostly numerical, like since we have discussed all the uh, uh, okay, since we have discussed all the queries, like all the weeks, week 1 to week 12, now we are planning, we have one more live session left because the PMRF live session we started, it was a week late compared to your schedule. So what we can do is we can have one live session discussing the problems from all the week content. If you guys have any specific query to deal in that week, you can tell me. So you guys will have four live sessions hereafter, which will be regarding general content, like from week 1 to week 12. We have, as of now, KPC Rao has requested to take numerical questions. Whatever numerical questions is there discussed in the previous classes, he wants to discuss the numerical questions, how to solve those questions. Do you guys have any specific requirement to discuss in the class? If it's there, you can type in the chat box or you can tell me after unmuting. Okay, so we plan, there is no response now. Okay, you can think about it and you can post. So mostly the questions, whatever for the main exam, it should be, it not be just as same as the assignment questions, but it will be like that, I suppose. It will be objective only as I observed from uh, Manus's discussion. Objective in the sense, it will have fill-ups, it can have numerics, uh, but and it can have choose the best answer type of questions, whatever you got from the assignment questions, not
For,
descriptive and not
uh,
no negative marks. Yeah,
just to pass the exam, whether we can focus on these live section questions and the assignment questions itself.
I won't suggest that.
Hmm.
Obviously how the questions came in the assignments, or in the live sessions can't be the, like, maybe I would say maybe 1 in 100 question can be the same, but but the con- but the content discussed, you can go through it and check whether you guys are able to follow up and can revise using that I can suggest. But no,
Hmm.
going through them only, I will not suggest. Please go through the PPTs and revise. And if you have any queries, we can discuss that in the next live sessions. Since the students' numbers are less and we could not engage with, since we have 3 live sessions per week, we can't have more questions also.
Hmm.
So we are stopping the live session by 1 hour itself. But that days we are planning to take 2 hours live session, as we thought we can take the live session for 2 weeks, so 2 hours. So be come prepared, go through all the questions. Please come here and ask if you have any queries. We'll be able to address. And if you post any question discussion forum also, I'll address. Last week I've addressed all the questions, even if it's relating to like, yeah, like about exam cancellation also. About that also I've replied. So if there is any questions also, I'll address in the in the discussion forum. And we are planning to float a Google form in the announcement tab, saying that what are the topics you guys wanted to interact or in the next live session. Like that we are planning to float. Maybe in 1 or 2 days we should float before Thursday or Wednesday. Oh, Wednesday is tomorrow, right? Okay. So before Thursday, try to give your inputs to that. Yeah, that's it. Okay, then we'll end up the live session here. Thank you for being so patient. And please go through all the videos, or if you're not possible, at least go through the PPTs and see what you guys are able to understand. I wish you guys all do perform well in the exams. Thank you.